Panel and start the presentation. Thank you very much.
Thank you, Mr. Chairman. Good morning, ladies and gentlemen, and thank you, Integer organizers, for giving me this opportunity. Technical solutions for BS compliant heavy duty vehicles is the topic that I have chosen for my discussions with you today. Before that, I'll just try to give a brief about ARI and the division that I am belonging to. ARI is a independent R&D and testing institute in the India, and doing three types of basic activities. One is homologation and certification for the vehicles, engines, subsystems, components. We give technical support to government bodies, various ministries, and we do a lot of development work in the areas of powertrain, NVH, vehicle dynamics, vehicle systems, fatigue materials, and electronics. This is the division which I am connected to directly, is the powertrain design and development, and we have different service areas. For example, designing of engines from scratch, upgradation of existing engines, working on thermodynamic simulation, mechanical design and simulation, combustion and emission development, etc., etc. Using different fuels, diesel, of course, is a prime activity that we carry out. We do a lot of work on alternate fuels, hybrid fuels, and a lot of work on transmission development and hybridization we have initiated. These are some of the engines which we had chance to develop for various customers within India and also for some overseas market, ranging from as small as three-wheeler engine to as large a engine used in the commercial segment. And this slide shows some of the major achievements that we have recently developed. A 75 kilowatt per liter three-cylinder engine for passenger car and SUV application. We have also developed a 29 kilowatt per liter heavy duty engine and a stationary engines of about 24 bar BMP level for CPCB2. And we have several engine projects to our credit, different types of engines developed for different applications. And out of that, around 15 engines we have developed where the engine designs begin from the concept. These are some of the competency areas which we have established over the years, and some of the new areas which we are working. So we are now working on new areas, like we have picked up new topics like working on natural gas DI engine development. We are working on hybrid engine development for small commercial vehicle. Considering the future requirements, we are now trying to explore the possibilities of new advanced combustion concepts so that we can take advantage of some benefits of lowering NOx and particulate emissions together, and also give advantage to some fuel economy, keeping the heavy duty application as the focus. We are also trying to work on smaller engines like a single cylinder and two cylinder engine, which is very primarily used in different applications within our country, and those engines are really going to be having a various issues in future to survive, because the expectations are going to be very high, but these engines are very small to do the job for which they are working today. Some boosting is required. So we now believe that turbocharging may not be a right solution for those engines. That we are working on supercharging. We developed 6 engines so far, single and two cylinders internally, and found very good results on supercharging, and we want to do much more work on that. Similarly, going beyond engines, other areas like transmission systems, particularly AMT-80 for heavy duty applications, particularly for city bus application, is the other focus area we are working on, and of course on hybridization. Now, coming to the main topic, my earlier speaker, Mr. Ben Sharpe, has already talked much more than what was expected, and I'm very thankful that he has talked everything that I wanted. So, I'm going to be very helpful, and along the nation's policy, my nation's policy, that I can leapfrog many slides. As we all know, mobility and mobile are the two things which we need everyday life. We are addicted to it, and it's close to our hearts, and everybody wants to be mobile every day, every moment. However, in Indian scenario, many things which is very typical, the traffic management, road infrastructure, driving habits, and our culture of driving, discipline, repairs and maintenance, that culture, fuel quality controls, affordable technologies, comfortable uh, ride solutions, economics of operation, very important, etc. These are very typical and very specific for the country, and we have to give emphasis to this. Similarly, we should believe very strongly that whatever is very nicely happening and nicely working in Europe, US, Japan, and other places may not be very fit directly to the India. Therefore, cut and paste will not work, in my opinion. We have to develop the things suitable for us, fit for us, and that is what is very important. That we should answer every time 5W1H, what is rightly required, when to implement, why a particular solution is suitable for us, who will be the beneficiaries, where do we bring the technology from, and how to make all these technologies as fast as possible indigenous so that we get the benefit of cost advantage. So these are some of the things my personal perception. Uh, as far as heavy duty engines vehicles are concerned, which I'm going to be talking next 15-20 minutes, increased power, everybody's talking downsizing or whatever we call it. Then fuel consumption is of course a major task that there is no compromise, there is no two discussions, and with lower weight. These are the three parameters on which everybody has to work. And today heavy vehicles in India, they are largely powered by diesel. Yes, there are some introduction of CNG vehicles, but in future dual fuel applications running on diesel CNG, running on hydrogen CNG. There is now room for such fuel for power plants in BS6, ethanol, biofuels, other fuels like DME may be thought of in coming future. Hybrids for heavy duty vehicle is also going to be a major role playing. There are also going to be some change in scenario in Indian perspective, particularly where SI engines like gasoline engines may be considered for some application in coming days. Today, India has never thought about gasoline engines for heavy vehicles, but the day is not far when something may happen in that direction. Full electric and fuel cell, yes, it's long way. I do not know, many of us may not be even see that scenario running on the road, but in the future. And today we are trying to work on low carbon fuel. A day will come when there will be no carbon fuel like hydrogen. I will skip this slide because already it has been covered that there is a tremendous reduction in the overall emissions, particularly from NOx and particulate expected as far as BS6 is concerned, going from the regime of BS3 and BS4. A lot of challenging involved. And the BS6, which is now in front of us 4 years from now, that is April 1, 2020, which is now final notification in hand, and all stipulations, all everything is clear, roadmap is clear to all of us. The scope is quite different in case of BS6. We all are aware of it. I will not dwell on that, but there are additional requirements like lower NH3 emission values. PM mass is always there, but now the PM by number is introduced. Durability concepts, more stricter OBDs. There is a WNT cycle. There is a RDE cycle for test data only, and in-service conformability. These are some of the new things which we have to handle now when we think of making our power plants suitable for. And it is also shown that the new cycles which are now going to be covering BS6 like WHTC and WHSC, etc. They are different than ETC cycles and EAC cycles that we have been using from Euro 1, Euro 2, Euro 3, even for Euro 4. How they are different? They are different from the point of view of the pattern in which they are working. Now we are going to be seeing that most of the time there is going to be a scenario where lower speeds and higher load operations will be more prominent for new cycles which are being discussed, which will have tendency of more NOx generation. And of course there are also going to be equal scenario where exhaust temperatures in reality may be of the lower side. So these are the two challenging scenarios on which we have to work and develop our technology. And in my opinion, this is going to be more worse for the India. Similarly, uh, instead of developing our power plant for only the cycle for which we have to do the type approval to make sure that we really represent real life situation. There is a not to exceed concept also added, which is more representative by this particular map. Therefore, while working on the power plant development for emissions and all that, we cannot just confine to those certain cycle, but we have to add additional work so that any point picked up during in that map for two different types of scenarios should meet the emissions. And idea is that we do not do the engine development or powertrain development for only meeting the cycle or meeting the specific type approval, but it should be realistic, close to what is going to really happen in the field. Now, out of various emission limits, we have to give more emphasis on emissions coming from the engines, but pertaining to NO2, particle number, and CO2 of course. Because CO2 is nothing but the fuel. And we all know why NOx is going to be very important. And in that NOx, NO2, because NO2 has got more direct impact on the health, more direct impact on the environment, and need not read all those things. Similarly, particle, we are aware of it, about its issues related to health and ecology, soiling, etc. And we find that NO2 is going to be a more prominent source of concern in coming year, though we are not talking about NO2 specifically, but I understand there are certain discussions going on in Europe, where in next regime probably they will bring a special emission limit for NO2 out of NOx. So we will have to be prepared for that in coming days. As far as particle is concerned, yes, we have been reducing the particle, and reduction in particle has really reduced the mass, really reduced the size, but the number has increased. And this particular medical report shows that smaller the particle size, then it can get into the lungs directly and can do huge damage to the overall body. Therefore, particle number reduction is important. Particle number reduction means reducing the number of the smaller sizes, which can be inhaled very easily inside the lung. Therefore, particle number reduction is the new thing which we have to meet. Lot of technologies we have been depending on common rail injection system over the years. Huge work has been done in common rail development. Injection pressures have increased from 1400 bar now to 16, 18, 2000, 2400. There are reports of 3000 and beyond also. And these technologies have classically improved the particle emissions. But at the same time, there is going to be much more in work involved in reduction of the NOx. Particle reduction has been achieved to a greater extent by engine combustion development. But when it comes to number, it is found that we need some after treatment. Otherwise, if it was only particle mass as the limit for us to meet, probably we would have been in a position to avoid any kind of after treatment like DPF and would have achieved it. But since number is there, today there is no solution available other than DPF, and DPF is going to be there because number has to be met. The introduction of particle number is going to make DPF essential. This is what, in my opinion. The targets, of course, it is NOx, particulate, and fuel consumption. Exhaust gas recirculation, we have been using it for last decade, and it has been a very straightforward improvement in NOx reduction quality, but it increases the fuel consumption. It also increases to greater extent engine out particulate emission. This is one of the disadvantage, and it principally reduces the NOx formation during the low load operation and not during the real world high load operation. This is one of the things which may not work well for BS6 what we are going to have. Oxidation catalyst is going to be quite prominent now. It reduces PM emissions, but not every part of the PM emission, and it removes the soluble organic fraction. As we all know, it is very sensitive to the sulfur content in the fuel. Therefore, at least less than 500 ppm sulfur is required. But now we are talking about 300 ppm down to 50 ppm in days to come. DUC is also going to be very vital whenever we are going to use SCR, because SCR is going to be one of the major source of after treatment devices for BS6, and whatever DOC we put in front of the SCR may help in improving the conversion rate of SCR, and DOC may also help in regeneration of some of the passive types of DPFs. Selective catalytic reduction system is certainly going to be a major theme in front of us. EGR is not going to be the solution. Alone EGR will not work. We need to have either SCR or in combination with the EGR depending upon various scenarios in front of us. There is no time to go into more details about all these things. The diesel particle filter is essential, no discussions, because number has to be met. But there are now solutions coming up. Now vehicles, there is a space crunch. There is no space available. SCR is required, DPF is required, DOC is required. Many other systems are coming up. Where to put all these things? The integrated solutions are being discussed. They are being introduced. They are being proven also in Europe and other places, where SCR and DPF can be combined together, and then we can use this concept by reducing the space that is involved in the after treatment devices. Now EGR, EGR plus SCR and SCR only, these are the three scenarios in front of us, and each one have got their own merits and demerits, and based on this we'll have to find out which is more prominent for various applications, various vehicles, vehicle sizes and end application, and according to that probably SCR and SCR and EGR will be the two things which will have to be working with some of the demerits in front of us. Because time is short, I only 5 minutes in front of me, so I'm going very fast. As far as various strategies are concerned, now we are finding that the trade-off between NOx and particulate is what is eating away uh, the activities of the engineers. This big challenge in front of us. Therefore, there is a opportunity like HCCI type of concept, BCCI type of concepts, or low temperature combustion development concept, which has got some room where NOx and particulate can be reduced simultaneously, and also gives a benefit on fuel economy. These are the reports. Based on this report, AR has also started working on LTC combustion development on a heavy duty application, and this is one of the future prospects we see, that probably if we get success in this particular combustion concept development, we may come out with a solution where a low NOx, low PM uh, system configuration can be offered for heavy duty application, lowering the size, lowering the after treatment loading, and also giving benefit to the fuel economy. And we are quite interesting to get our initial results based on our HCCI work, and we find that next phase of work that we are doing on LTC will be quite helpful and successful. Therefore, the question is there an alternative to the conventional practices that we have? Yes, there are many such solutions, and we see opportunities in HCCI, PCCI, and systems. Various types of combinations of advanced in cylinder combustion processes, combustion after treatment systems are being discussed. Catalytic material like zeolite, vanadium, all these things are considered. Each one of them issues related to the temperature. Zeolite works at different temperature levels. Copper material work at higher temperature levels as far as conversions are concerned. In the Indian scenario, we have to find out one place is the cost, other side is the reliability of operation. So therefore, the catalyst material and the choice of the material from the point of view of cost and reliability of operation and real drive emission has to be met. Therefore, there is going to be a lot of debate between zeolite based and copper based catalytic. These are some of the examples what people are doing globally. The exhaust gas after treatment system, therefore, in my opinion, needs to be effective in a wider temperature range, have a higher deposition rate of pollutant removal, and should have no negative impact on the fuel consumption, because that is very prime. And there is an example which I could get, that Scandia's D13 engine has shown that there is a trade-off between efficiency, engine efficiency and NOx emission, and 1% fuel economy improvement has shown an increase in NOx raw emission from 10 to 14 gram per kilowatt hour. This is how the trade-off is there, so we have to be very careful scenario. And there is also a significant progress in improving heavy duty engine efficiencies, 50% or more thermal efficiency being discussed and being worked out. And though uh, truck and trailer modifications, freight efficiencies can be increased by more than 80%. Trailer modifications in particular offer large gains for a very small investment, and DPF development are focused on ash management. And for the success of SCR on filter system, it is important to find the optimum balance between good DNOx performance and sufficient particle filtration efficiency. On one side, again, increase of back pressure should be considered a challenge. Here we can see that SCR, GR plus SCR and SCR alone, what kind of cost benefits and cost ratios are involved, and it is found that SCR alone, if we can use, it will have a lot of cost effect. Many types of architectures are available. For example, SCR in front of DPF or DPF in front of SCR or combination, etc. And all these things have got different merits and demerits. It has to be studied properly for the given scenario, and then we can consider which one is going to be more effective for type of application. The temperature of diesel exhaust gas is relatively low. This all we know is the typical characteristics. And SCR system is more efficient at higher temperatures, but the real drive solutions where the loads are heavier and temperatures are low, we have to find out how this SCR can be more efficiently used, and whatever type of approval data we get, what is going to be there in the real life solution. This is the ICCT literature which I am quoting here, where they have showed that as far as the gasoline engines are concerned, type approval data and the data realized on the real field, they are very closely matching. But for diesel engine on the right side, the red one, there is a tremendous difference between the two as far as engines which I could get up to Euro 4 and Euro 5. But here shown now the Euro 6, but there was a good agreement between the type approval data and the data realized on the field. So we hope that this will function, but we don't have any hands-on experience on BS6 as on date, but we believe that the data presented by you will hold good in Indian scenario also. But in my opinion, compared to Europe, there will be worse condition in India because our driving patterns are different. We may be running at a lower temperatures compared to what is happening in European condition. So therefore, the problem definition today is, in spite of all these things done, CNG is brought, lot of emission regulations have been brought in the country. Still, urban air pollution is not improved. There is a difference between the lab test and the actual driving emissions coming out from the vehicle. This has to be tackled. While working on emission, we cannot forget on fuel efficiency, that is CO2 emission, which has got direct link to global warming. Therefore, a lot of efforts are required to be done to improve the fuel economy from engines, from power plants, and some of the things which I can read from here, the strategy like advanced boosting concept, charge air cooling, exhaust gas energy and heat to coolant losses, and air drag and rolling resistance on the vehicle side are also required to be considered. We cannot expect everything from the engine. We have to work on transmission, we have to work on vehicle. And India should drive fuel consumption and CO2 reduction program with 10 to 20, 15% reduction as the target in front of us. And these improvements can be achieved by addressing various things coming from engine, vehicle and transmission platform. On engine technologies, further downsizing, down speeding, Miller cycle, variable valve actuation, increased peak and cylinder pressure, high efficiency turbocharging, LTC type of combustion concept, robust engine designed to handle higher peak pressures of 200 and 220 bar, friction reduction, exhaust after treatment optimization, driveline and vehicle platform development have to work together to finally achieve the CO2 emissions. Heavy duty vehicles, my overview toward the end of the slides. BS6 emission reduction introduced not to exceed limits. This is something new. Other charges include the further reduced limit on the NH3 slip, NOx emission reduction, particularly NO2, which is not considered today as the limit, but we have to keep our development effort in such a way in future whenever there is a requirement to control NO2, we are prepared for it. Along with other concerns such as climate change and energy security, today air quality in cities is a major issue worldwide, and Indian cities are not different than that. Therefore, emission limit for NO2 is I have been now making myself prepared that we have to work on those lines in days to come. Indian Bharat 6 regulation has jumped through Euro 4 to Euro 6. There are now roadmap clear. Development time is limited, we all know. Many engines will be design improved from BS3 level in our scenario, and there is need to access best practices, shortcomings, and learnings from US and Europe, and customize suitable solution for enforcement, avoiding high level of NOx emissions coming from the vehicles in the real field. And we have to work with a focus that we should design in India and design for India, because I keep reminding myself every time. Cummins says the quote, the right technology matters, unquote. Thank you very much. I think I'm in time.